Electricity is vital for almost everything we do nowadays. From powering the lights you can see from this satellite image, to heating your home, heating your water, cooking, basically everything. Now, the problem with this is, as dependent as we are on it, that leads to a lot of risks. Anything that could damage our ability to produce or distribute electricity could have massive detrimental effects on society. Depending on what year the sun is in its cycle, it performs something called a coronal mass ejection around 1 to 4 times a day. Now what this is a large cloud, essentially, of the sun's material being flung out at high speeds off of the surface of the sun. 90% of the time, this doesn't matter. It'll completely miss us and just fly off into deep space. However, if one of these ends up colliding with the Earth, it can have extremely detrimental effects. In 1959, something referred to as the Carrington event occurred. This was an extremely large coronal mass ejection that collided with the Earth's magnetosphere. As a result of this plasma interacting with that, it released an absolutely enormous amount of energy, on the order of terawatts. For reference, that's more than 1 million times the peak energy usage of all of New York City. The electric fields generated from this were so strong that telegraph operators reported their machines flinging sparks out. And even after unplugging the power source, they could continue to use them due to the amount of electricity generated through the ground. Now, as dangerous as this sounds, the key problem is mostly with our power grid. Unlike you may have seen in a movie, something like this is not going to damage your cars, small electronics. Most of that will be fine. But our power grid, on the other hand, will take very serious damage. Unfortunately for us, there's nothing we can do to stop this. The sun happens, we can't block it from hitting us. All we can do is try to predict when this is going to happen and how damaging it'll be. So the way to do this is through anticipation and isolation. Fortunately for us, NASA is already working on this first part. In 2006, they launched a satellite program referred to as STEREO. 2 satellites sent in opposite directions around the Earth's orbit are sent to monitor these coronal mass ejections in exactly the same way your eyes detect depth perception. Using 2 satellites in combination with another one on Earth, they can create a very accurate picture of where the coronal mass ejection is moving, how fast it's moving, how big it is, and all kinds of other data about it. As a result of this, we'll have about 2 days warning in order to prepare and prevent massive loss of power from happening. Unfortunately, in 2016, due to one of the satellites developing spin and losing power, we lost connection with one of them. NASA's currently trying to work on how to regain connection to that, but up until then, we're slightly blind. One of the satellites will still be slightly effective, but not nearly as useful as 2. Now, predicting these events is not enough. Obviously, if we know it's coming, that's a good thing. But if we don't have any way to stop it from damaging our power system, then what's the point? We just know something bad's going to happen. The main issue with these coronal mass ejections is it damages both the long-distance transmission power lines and, more importantly, the massive transformers at the end of each line that are responsible for distributing energy away from power generation and to our homes. The problem with these things is they're enormous. They're very difficult to replace. By difficult, I mean you can't repair them on site. The only way to do it is to build an entirely new one, and that can take up to 12 months. So in 2003, there was an enormous blackout that lost power for millions of people in the Northeast. This was national news. It was an enormous event, and most people were only without power for 2 days. Imagine how bad it would be if large parts of the country were without normal power for more than 12 months at a time. Absolutely catastrophic. Now, once again, NASA has put in a plan to do something about this. using the data from the stereo satellites and other sources in combination with extremely powerful computers. NASA can take the data and plug it into a series of equations that will allow them to determine where the current moving through the Earth's crust and dirt will be the strongest. Now, once they can determine where this is the strongest, they can figure out which transformers will actually be damaged by this and disconnect them from the power grid before they explode. Doing this, unfortunately, will cause a small blackout as a result of not having the transformers, but having them disconnected for a day or two is much better than having them disconnected for 12 months. Now, there was a point to this. Not just trying to scare you about something that we have no control over that could lead to the end of life as we know it. The fact that all of this has something in common: NASA. Now, as most people's understanding of NASA is, oh, they're there for cool pictures. They're there to do stuff that no one really cares about. So not only is NASA responsible for predicting and preventing catastrophic events like being hit with a coronal mass ejection, they're also in charge of all kinds of other things like the weather and predicting the weather, charting the weather, all kinds of other things that are essential for our daily lives. Despite this fact, the budget for NASA has been steadily declining every single year since the early 1990s. And as far as current trends go, this is going to continue. Now, continuing to support places like NASA is our only option to not only ensure the survival of our species on the planet and how we're doing, continuing our way of life, but not only that, but continuing to make sure it's comfortable and we know how the weather is going to behave and how life in general on an everyday basis is going to happen.